Test and Design webinar, Shake, Bake, and Contaminate, Mil Standard 810, Environmental Requirements for Military Equipment. My name is Belinda Stashukevich, and I'm the editor of Environmental Test and Design. Environmental Test and Design, which launched in 2009, specializes in the interrelationship between electronic systems and devices and their environments. This webinar is presented by Steve Ferguson, Executive Vice President of Washington Laboratories. Steve Ferguson has worked in the compliance test arena for over 35 years at test labs and manufacturing companies, designing products, developing procedures, and performing tests. He presents various courses on EMI and EMC compliance. He is an INARTE certified EMC engineer and administers the INARTE approved Washington Laboratories Testing Center. This webinar will be interactive. You will be able to ask questions and answer polls, and we encourage you to participate. Take a look at the GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or to report an issue, click the hand icon. And to maximize the screen, click the middle button. We will present the topic for 45 minutes, followed by a 15-minute question and answer session. Before we begin, we have a poll question for our audience. Attendees, please answer the following question. What is your primary job? Product design, product evaluation, product testing, or other? We will give you a few seconds to answer the question. We see about half of our viewers are in product testing, followed by product design. Thank you for answering the question. Steve will begin the presentation.
Well, good afternoon and welcome to everyone. I appreciate Environmental Test and Design for giving me the opportunity to present today. We're going to primarily discuss Mil Standard 810. Revision G is the current one, and we'll discuss things associated with it. The title indicates that it's a test method standard, but the reality is it's much more than that. From a program management guide to the engineering process guide needed desperately to determine the requirements, the test methods and options for tailoring, the engineering guidance, the basic test procedures and handling situations. What do we do about various things that arise during tests? The definition provided on basic test levels, and there is a guide on climatic conditions to help the developer understand what his program should do. The environmental tests in Part 1 are specified. Test 401 means the engineering and management plan. Develop the process, what's going to happen here, where's the life cycle, what is the overall requirements for developing a product and getting it to where it will endure the hardships of the military cycle. The life cycle environmental profile obtains data where this is going to be. Helps us decide which tests are appropriate without an over-test or under-test or just simply testing for the purposes of it. The life cycle plan is critical to getting product development correct. The operational environment documentation gives a history of where this thing needs to be, what needs to happen, and that supports our environmental issues and criteria list, where the program developer decides what is appropriate, what do we need to test, what do we need to analyze, what do we need to ignore, what's associated with that. That sponsors the detailed environmental test plan. This is the item that tells all the test labs, all the test people, what they should be doing, what limits, what profiles, what fluids, what everything should be done associated with this. This is typically one of the most lacking pieces that we get. The test lab will be asked to develop the criteria with no life cycle plan or none of the information feeding it. The standard's pretty specific about not doing things unnecessarily. Obviously, after the detailed testing, the reports are a direct derivative. Should come into this. We need to come up with these places where this criteria list defines a decision on testing or modeling. This is where that whole situation comes about and supports the development. That information makes the program work for us all. There's several test methods in Mill Standard 810, as you can see by the list, from low pressure to multi-exciter and mechanical vibration for shipboard. A lot of these tests have been around for a long time, and associated with those tests, you'll have a decimal place like 500, 0.6, or 0.5, depending on which Mill Standard revision was associated. So the decimal place helps us decide which one's in play. We'll be going through each of these, at least a little bit of them, and getting an overview and decide that. As you can see down here, 5 new requirements were added to the 810G. I've identified those in the italics. So you'll be able to see those as we progress through this. Other standards come into play quite frequently. The 668 series for the IEC, International Electrotechnic Commission. Mill Standard 883 for microcircuits, 202 for components. DL160 has a program for commercial aircraft. Mill Standard 167 deals with mechanical shipboard, internal and external. But in each of these documents there's a common theme: tailoring and life cycle considerations. This always feeds through to get the right thing done, whether it be a longer endurance test or a shorter test to get a snapshot of what's going on. And all of these define qualification testing. There's also some attributes associated with development to help us decide how to design the product, get sample pieces, packaging material gets developed, things of this nature to help develop the overall program. Tailoring is a common theme, and we use it almost every time, whether we know it or not. The tailoring helps us develop a program based on common sense considerations, the material, applications. What are we trying to prove? What are we trying to satisfy here? The details of the evaluation process and the method details. Exactly how to proceed. What categories and extreme conditions could be encountered and how we should apply those. Obviously, there's many test methods in here and lots of options under each of the test methods. So we need to consider those kind of aspects. Any special conditions that would be involved. How do we configure the unit? How do we expose it? Is it a package test? Various things come into this overall tailoring process. And a sequence. Several selected methods are defined, but you need to use engineering judgment if not defined. What will happen? Here's always a problem I run into is once you tailor it, how do you get it accepted? So that needs to be driven from the contract down to the testing lab versus the opposite direction. We seldom see that, but we need to see more of it, be more interactive with our customers, develop things appropriately, and they go into the acceptance of this. A lot of contract officers and technical representatives think we're trying to shortchange the process, so they tend to be difficult to accept to tailoring. So your tailoring process needs to justify, rationalize, why are we doing what we're doing versus some other method. When the specifics are not clearly defined, this becomes even more useful.
Steve, I'd like to interrupt you for a minute to ask a poll question to our viewers. Attendees, please answer the following question. Before we get started in discussing the various methods, how many new test methods were added with the release of Revision G? 3, 4, 5, or 6? We'll give you a couple seconds to answer this question. About 60% are answering 5. Thank you for answering, and back to you, Steve.
Okay. Let's deal with interruptions. As we go through the testing, there are lots of things that cause interruptions. The intolerance interruptions, things where the conditions are maintained, are not considered an interruption at all. However, out of tolerance interruptions, and I want to say not the test article failure, but throughout the whole mill standard there are, if the test article fails, what to do. And that has to be decided on a case-by-case basis in a lot of instances. Sometimes you may have several test articles available where you will have a parallel testing program. In other cases, a very expensive item may be one of a kind, so you have to really look at the sequences and potential damage and how to proceed, which tests need to be repeated. We'll kind of broach that as we go through the various ones, but the methods 503 and the others listed on that line have very specific things developed to say under test you resume it after reestablishing the tolerance from the point where you got out of tolerance. So, for instance, you're doing a temperature test and you lost power to your chamber and the temperature fell. Simply go back to the point where it left and resume the test. An overtest, you might have to start over with a new test article unless there's been no damage. So you have to really analyze it and study it. The methods 500 and that series, each method has specific instructions for handling interruptions. Almost all of these follow the general methods as we talked about above. However, sometimes there are some critical features, so you have to look at each one of those particularly. Most methods have some sort of specific if the test article failure happens. In general, the analysis, repair, modifications, and start over with the test. Common sense says that just starting the test where it broke is not necessarily valid. If some prior test could have contributed to the failure, for instance, a thermal test may have caused an expansion, so the immersion test caused a leak. So redoing the leak test with a new product without the thermal expansion and contraction cycle may not be adequate to determine what you need to do here to repair it. You may not have a compliant article because of some other feature. So we'll make sense out of this and look at contributing factors. Analyze why it failed is always a necessity. Let's get into the various methods here. Method 500, low pressure, or commonly called altitude. Evaluate material that's transported or exposed to rapid explosive decompression, carried externally, stored or used at high ground elevations. Determine which procedure needs to happen in your tailoring. There's various procedures for the operational, transport, exposure for rapid decompression. So how fast does the change need to be? Rapid decompression could indicate various things. Usually the test duration is about an hour, but sometimes tailoring calls for longer durations for things that could be affected. What kind of test configuration do you have? Is it a shipping thing, an operating thing? What are you going to do here? So the tailoring needs to specify all these various conditions. In this case, an interruption is not permitted. The sequence should be after a temperature cycle, dynamic tests such as vibration, or the aging of non-metallic parts. Glass delamination can happen, things of this nature. High temperature, evaluate surface stability, overheating, mechanical binding, failure, etc. Shortened life, you have all kinds of things that temperatures, especially high temperatures, cause. Procedures need to define for storage and operating, or they are specified for storage and operating. And the tailoring is based on your climatic zone. Where is this deployment going to happen? Is it a hot, humid environment, a hot, dry environment, extremely cold? What's the thing? The test durations are defined, and you need to specify whether it's a constant or cyclic. Most of the standard calls for some sort of cyclic program. However, constant temperature exposures at a fixed level is sometimes substituted as an operation or storage configuration, or some of both. In a lot of cases, storage configuration is an extended period that calls for some operational checks during the period. However, storage configuration could be inside a container that prevents you from doing that. So we have to really look at how that examination happens. Something needs to consider stabilization. How long does it take the item to get to a temperature? If there is a huge mass of material, it takes quite some time to change the temperature. So we need to consider stabilization. Most of the durations call for stabilization plus the exposure period. And again, humidity could be called out, especially if it's extremely low humidity can affect the operation. Interruption and overtest, inspect it, determine whether you go back to the test or not. And under test, simply resume the test. Early in the test sequence is where we want to do it because it's typically not damaging. But you normally want to get your vibration and shock and before the low pressure test. So vibration and shock should be in there because the temperature could affect things that have already been made loose. Low temperature, again, the same kind of items happen here, the performance and binding, etc., shorten life, and the uneven expansion. Freezing and condensation could come into play, but there is a freeze-thaw system been added to the standard. Procedures call for storage, operating, manipulation, just like the temperature, the high temperature, climatic zone, the deployment, whether it's sheltered, exposed, durations. And normally a constant exposure is dealt with on this particular item. Whether it's an operational storage, and again, stabilization, much like I had before. This manipulation thing could come into play because if you have to operate switches, buttons, latches, etc., while it's extremely cold, you may need a chamber where a person can enter and wear cold weather gloves, etc., to verify they can operate. So selection of where you do the test is a function of this manipulation requirement. Sequence is determined, but early in the test sequence is usually the case, again, after vibration shock and before altitude. Temperature shock. Purpose, effect, sudden change. How fast is a shock? Well, if you think about items that go from a warehouse that's heated or a maintenance shop where you take items out and install on an aircraft in a cold weather climate, you can get an extreme shock at a very rapid pace. How long to expose the item and how many shocks? Do I leave it at the temperature till it stabilizes? Usually that's the case. You need a stabilization period. But the transfer time, do we need to switch it in 1 minute, or is it just a rapid change like 10 to 15 degrees per hour? So it could be either way. Interruption of the test, restore the previous conditioning, continue the overtest, and you inspect it before you continue. Obviously, if the inspection is not valid, you need to worry about it. The sequence isn't specified, but normally the temperature tests indicate a sequence need. If you have cold issues or hot issues, you may need to look at that being a party to this job. Fluid contamination. Obviously, this is the one that causes most labs the most grief because we've got to handle fluids that are not necessarily nice to handle. They have corrosions, etc., and we have to be able to dispose of those materials, etc. This is also has some various procedures where you dip the item into it, spray, immerse it. What fluids are applicable? It's almost insane when somebody says, well, the whole list, because you're talking about an extreme amount of fluids, an extreme amount of time, and the duration for these things, plus handling all those fluids. It's obviously there, but if it's never going to be exposed, why would anyone select to do these things? So we need to look at the application to make sure we're choosing the right methods, or else we severely over-test and expose products, and it's not an inexpensive proposition. The application method needs to be determined whether it's sequential or multiple fluids exposed at the same time. Any sequence, you need to clean it between the fluids, things like that. Which sequence do we operate them in? These need to come out of that life cycle and or criteria development thing where that procedure, that plan defines what we're doing here. Interruption and overtest or undertest, both of them inspect it, determine whether to go forward or not. Sequence is not normally before other climatic events. So basically we need to get some temperatures, exposures, and things like that before we run this fluid contamination. It may provide for gaps and seams that leak fluids. Solar radiation, direct heating or actinic effects, photodegradation, fading, etc. A lot of these things come into play when in developing outdoor products, things that mount on vehicles parked outside all the time, constant exposure to the outdoors, including the heating effects from storage in an outdoor environment. The tailoring calls for cyclic heating, the procedure calls for cyclic heating or some steady state condition. You may need full spectrum lighting. The light sources for solar radiation contains pretty high frequencies, a high spectrum of the energy associated with sunlight. Specify the levels, how many cycles, duration, how many test configurations. These are not difficult tests, but they do require control chambers and large sizes for these various products, some of them vehicle sizes and above. So picking the location could be important. Interruption, enter test, resume it, or you may consider it complete depending on how far you got into this thing. And over test is inspect it and determine whether to go forward or not. Sequence, not before vibe. I'm not exactly sure why not before vibe, but that's one of the call-outs in the standard. Another question here, Belinda?
We'd like to ask another poll question to our audience. If the environment is defined as constant high humidity, does the testing call for a cyclic profile? Steady state profile is substituted. Constant temperature with minor humidity variance. Constant humidity with minor temperature variance, or cyclic temperature and humidity applied. We'll give you a few seconds to answer this question. We're getting in a lot of responses, and the majority has gone with constant humidity with minor temperature variance. Thanks for answering the question, and back to you, Steve.
Well, let me go back to that poll question. It's a good thing. It is cyclic temperature, and with a constant humidity is the normal call-out. But remember, when you're changing temperatures, you will get a variance in the humidity profile, and that's normally allowed. So let us continue. The rain test of things outdoors encounter rain quite often, or sometimes we think it's raining inside when the humidity climbs sky high. The performance and effectiveness seals, covers, packaging, any water removal system. If there is rain or blowing rain, water tightness, or drip test. These could go from a high exposure with high wind rates to a dripping system, and an immersion could be included in this. It's usually not. It's a separate immersion test. But some people look at it as saying they need to expose it totally, and the immersion is the way to go. The tailoring has to specify various things here: the rate, drop size, velocity, pressures, orientations, durations, temperatures. These are things that have to be determined how we're going to do the test. And in the absence of this information, the standard doesn't really give you good ideas. They say, well, typical drop size is. And we usually go that way in the absence of any tailoring information. The general interruption happens much like anything else. Under test, resume it, over test, inspect it, and decide whether you're going forward with that article or not. The sequence, the preference is after dynamic test to see if we've shook open holes, things became loose, and etc. Humidity exposure, the purpose is warm humidity environment, corrosion deposits, delamination, fogging, you name it, goes wrong with it. The temperature and humidity needs to be specified with 5 48-hour cycles as the normal, so 10 days of exposure. Inspection intervals could occur during the process. There's usually at cycle 5 and cycle 10, but others could be. We had a program recently that had an evaluation every day. Operation periods and performance checks. Some aggravated cycle calls for these checks at the 5th and 10th. Interruption, the under test resumed from the end of the last completed cycle. Over test, inspect, test, and determine whether to go forward or not. The sequence, consider the effects on subsequent tests, but do not do this one after the salt fog, sand and dust, or fungus testing. They will affect the results of these items. Speaking of fungus testing, the purpose is the growth, see if any items, including the ability for storage and physical impairment to optics and material deterioration, growth of spores. Exposure to fungus and temperature, humidity to support the growth is called out. Normally a 28-day cycle, but sometimes an 84-day period would come into place. Inspection includes operational checks. So the history of using coupons or particle samples to see if it would support mold growth or spore growth, it's kind of went away because now they're calling for operational checks. So that where we've had a history of using coupons, we may have to change the process here. Interruption is detailed based on the point of interruption, humidity and temperature conditions were attained. The sequence, not after salt fog, not after sand and dust or humidity. Recommended to test a separate unit with minimal handling prior to test. The idea of handling the unit prior to test leaves body oils, handling, etc., any kinds of things that may support the spore growth and cause a failure that's not associated with the item. So make sure the article that goes into this test is in fact kind of a clean product without things that would support artificial failure. The salt fog test, it happens for a lot of the shipboard activities and things near coastal regions. The procedure calls for alternate fogging and drying cycles. Tailoring, do you really need to do the test? That's been one of the common things. The standard 48-hour exposure followed by 48 hours of drying. However, the more realistic test calls for a 24-hour exposure, then 24 hours of drying with 2 exposures alternating. That's what most people call for. The standard still says 48 hours exposure with 48 hours of drying. The temperatures, the salt fog fallout rate, and storage things need to be defined if they're different from the standard. These tests are pretty well commonly known and pretty straightforward, so there's not a lot of tailoring other than any high exposure times. Under test or over test, it's an inspect and determine whether to proceed or not. Sequence is not specified and affects, but assess the effects of other tests, especially after fungus and humidity. These tests call for an in-depth inspection. So taking the unit apart and seeing if we've had salt penetrate into the unit, etc., is a part of the overall job. So when you're considering how long you're going to take to do this, consider that inspection could be somewhat lengthy. Sand and dust. Assess the resistance to small particles invading openings, abrasion, clogging. They call for blowing dust and blowing sand. And section number 3 was deleted in revision G. It was an F for settling dust. You also have the test article configuration has to be defined, temperature, humidity. The duration is typically a dust is 6 hours plus 6 hours of an elevated temperature, and the sand is 6 hours. You may have exposed sides, so the orientation could come into play here. You need to operate during test. It's always a challenge to operate a generator, for instance, during the sand exposure, and you're pulling in air with the sand, and it tends to clog everything up. But the filters may need to be reestablished and continue. Over test, remove the excess, and resume. Sequence interaction with other tests are expected, so not prior to humidity, fungus, or salt. You may need some information from temperature testing to determine some parameters. So this is one of those that you may have to get a result on one test before you decide how to do the next test. This is one of those. Explosive atmosphere. Purpose to test ability to operate with the high ignition of fuel air chamber. The tailoring is applicable. What's the fuel vapor mixture, any temperatures? Does the item get hot to ignite the mixture, or is it simply from arcs from unsealed switches and contacts that may change? Humidity needs to be determined. The altitude, a max of 40,000 feet. Just today, we had a client specify 52,000 feet altitude. There's no air there to make this mixture happen. You're not going to support flame and ignition. So how do we call for it? Interruption, you purge your chamber and reinitiate the test and basically start all over again. And you need to perform temperature and vibration shock tests first, because that may expose cracks and openings that would allow the mixture to ignite. Immersion. The purpose is to look at equipment impairment, corrosion, explosive deterioration, engine operation, etc. Associated with immersion or fording. Some things need to be underwater for a period of time, others are like stream fording. The depth of the immersion for fording or fording conditions need to be defined. Typically, a 1 meter depth is called out for a lot of products for general applications, but some things call for operation at various depths. 20 meter immersion is not out of the question. They may need to operate at 20 meters immersion, so that's kind of a difficult test to get a dump tube at 20 meters tall. Most of the time we go to some sort of lakes or things like that. Test configuration is packaged, operational, or protected, and the duration, typically a 30-minute immersion. This preconditioned temperature a lot of times calls for you to elevate the temperature of the article 10 degrees above the water temperature prior to immersion. So it gives a chance for the sudden cooling and pulling in of the water of the moisture. After structural test, vibration and shock is a sequence. Consider after temperature if any seals could be affected. Acceleration. Purposes to perform withstand the inertia associated with acceleration and deceleration and maneuver forces. Structural operational crash safety. The tailoring gets to be defined for applicable procedures, the levels, orientation requirements, etc. Crash safety says that I absolutely have to have the mounting structure as it would be installed, or else I don't evaluate its ability to hold on to that structure or the structure to retain it in case of a crash event. And an under test is restarted and inspected if you over test. After high temperature tests is the most common place to put this thing. Vibration. The procedures are big. There's 4 general procedures associated with vibration. However, there's 25 categories to select from and 8 type tests such as development, functional, qualification, etc. Vibration characterization, the article configuration. How are you going to mount this thing? Are you trying to look at how it stays together? Or are there going to be fixture adaptations that says I'm going to dampen the vibration? So doing a test on a box that you clamp to a table, the shaker, is not necessarily evaluating its mounting structure or what happens. You could get a significant profile variance on the item inside because you don't mount it on a structure that would provide a resonance or a dampening of the vibration. So sometimes a clamp down method is artificial, but it's used commonly to evaluate what goes inside in what they consider to be a worst case event. However, it may not define that if I've got momentum that causes a resonance at a frequency because of the mounting structure. So this requires a lot of detail on configuring the test article and the tailoring. How is it going to be evaluated? What's the purpose? Under test, over test, pretty well defined. Resume where you fixed it. Tailoring is suggested, but generally follow the life cycle. Vibration is a tailoring process. It's not common. I had one process that had been qualified using the wrong profile, and when we put the right profile in it, the metal seams of the chassis broke apart because of the propeller frequency of an aircraft. So we need to look at really tailoring this thing and look at its environment. Acoustic noise comes into play for limited applications where you get high noise things from that are hitting the test article. The grazing incidents, some acoustic noise, the diffused field, cavity resonances could occur. Again, applicable procedure if it's appropriate. You need this life cycle plan to identify it. If it's not going there. We see very few requirements that actually ask for this kind of test, but it's critical when the application needs it. Interruption, continue from the point of interruption in the sequence. They suggest tailoring quite a bit. Follow the life cycle. Shock test is the most common thing associated with the vibe. They get done together in a lot of cases. Accessibility to handling, transport service, anything from packaging development so it don't drop when the truck driver delivers it, to crash safety. 8 procedures, and it excludes some things here that we touch on with other things. It does include drop testing. This always frustrates a lot of people getting their product qualified because we're going to drop it on the solid surfaces and damage it. They don't like to see the thing damaged during tests, but that's the typical way to get the evaluation. Sometimes procedures call for going on the a shaker table, and is it a waveform that's a sawtooth, a half sine, a trapezoid? How long is the duration of the pulse? Shock also gets into some time waveform replication, a new standard that was added, and we'll get to that as we go towards the end of that. Interruption is continued from the point of interruption. Sequence tailoring is required, depends on the purpose, life cycle parameters. And you're seeing a trend here also. Life cycle parameters come into play more frequently than we like to admit. Shock, deterioration from prior technical devices, mounting structures for explosive ordnance, things of this nature. 5 specific methods are listed and they're stated there. Again, the tailoring is really critical. Applicable procedural levels, what zones are you in? What's the spectral response curve on the waveform? The test configuration is usually particular to the procedure. You need to follow the procedure, the configuration of the actual event to be able to tailor this shock event correctly. Tailoring is required. It's usually late in the overall program unless you're developing the structure. Acidic atmosphere, the ability to stand explosive atmospheres, is similar to salt fog. But using the salt fog chamber to do this may prevent you from using the chamber for normal salt fog again because it's contaminated. Some facilities have a chamber dedicated to the acidic environment. The duration is 3 2-hour sprayings, and a spraying in the application calls for a fogging mist versus an actual liquid disbursement. 22-hour storage after each, and 4 2-hour sprayings of 7 days. Test configuration, got to define what's going on there. Interruption, inspect and evaluate in all cases. Overtest, stabilize it, and hold it pending evaluation. Determine interruption, do not damage it, restart where you did. After humidity or fungus, before sand and dust, or anything else that affects the protective coatings. Gunfire shock, those things that are placed on automatic weapons or nearby them where the shock of the explosion or the weapon causes issues. Again, sometimes this reproduction of a measured time trace, the method 525, comes into play. Stochastically generated measured time trace information or predicted input. Tailoring, the applicable procedures, any control options, how are we going to control the shock event and feedback from that. Where do we place an accelerometer to get a control point that we're going to accept that it's at the right level? The test levels are usually location determined based on the installation. So we don't know how to do the test level without guidance. The test duration is calculated based on the life cycle and any configurations. Again, the fixture becomes critical to determine how this affects things. Interruption, reinitiate from test being conducted. Component failure, replace it and start all over. Sequence is tailoring suggested with guidance, but generally after vibration and shock and before climatic tests. Temperature, humidity, vibe, and altitude. People look at this as all things combined, temperature, but normally it's some combination of those things like vibration and temp, humidity, temperature, altitude, humidity, and temperature. And it doesn't replace the individual methods, even though a lot of folks said, why am I doing both? It wasn't intended to replace them. The procedures for engineering development, flight or operational support, any qualification, tailoring, the definition needs to be there. Quite frankly, the most common things we see is temperature and vibration together. That tends to be the most common event that causes issues. Some interruption, use the interruption from the individual methods. Sequence vibration is performed first if performed individually. So you do the vibe before you do this vibration side. Icing and freezing rain, evaluate purpose on operations. Ice accumulation could be on defined sides to a specific thickness. Exposure, which sides are exposed is a tailoring process. How much accumulation? Do I need to do it for shipping? Operational during ice? Do I need to start the test after accumulation if it's an operational test? Sometimes flat antennas, the dome antennas get an ice accumulation buildup. So we might need to evaluate the antenna operation after the ice acquired, especially those with embedded amplifiers, etc. Interruption under test, reestablish and resume, over test, inspect it, check to see where you can go. After rain, before salt fog, and dynamic tests. Ballistic shock comes into the momentum exchange between bodies, or between a liquid or gas and a solid. 6 procedures are called out, but they call out a specific shock apparatus depending on the severity and mass. Each procedure calls for a specific approach, so we have to really customize this thing. Sometimes a custom test fixture is required to identify to support the testing. Operational requirements need not be specified because normally it's a single event that happens. Interruption, reestablish it and redo it, over test, inspect it. The sequence is not specified, but you have to consider there's potential damage. Vibroacoustic and temperature involves the acoustic items along with temperatures on externally carried aircraft stores. So things that are not external, this doesn't apply. So we need to consider that in your overall planning purposes. Several tailoring items need to be identified, from temperatures to acoustic levels, exposure size, accumulation of the events, operational during icing or after start accumulation. Excuse me, that's an error in the slide. That icing is not associated here. Interruption, analyze the cause and reestablish operations, inspect, test, and resume if you're going to overtest. Sequence is not specified, again, potential damage considered. Freeze-thaw, effects of liquid to solid change on the materials, effects on the moisture by dynamic change. 3 procedures are called out, transfers from fogging or deneural cycle, rapid exchanges. Tailoring needs to be brought forward is what's the configuration, ranges, stabilization, do you use moisture spray, do you use a misting, do you spray it and acquire it? How many cycles need to go from the freeze and thaw circles? Interruption, reestablish conditions and resume it. Sequence is not called out, but look for places where seals could be damaged. One of the new items comes into place is time waveform replication, where the life cycle has recorded a specific shock or a single exciter, single axis waveform. The field measurements come into play, and that waveform is generated to control the shock of the unit during the test. This is a new feature because they're trying to absolutely define what's appropriate and what's damaging without over-testing in a general nature. Interruptions, we need to analyze, inspect, and resume. Follow the guidance for any test article failures. After vibration and normal shock is a sequence. So the time waveform replication will be coming forward, I'm sure, as time goes on. So that means everybody with these vibration systems and shakers that do these things need to have a software that will support the time waveform replication in the near future. Rail impact associated with handling things by railroad car during transport. Normally it's a packaging thing. How will we use various packages? Do we need to tie them down, like if we put a vehicle, like a military vehicle, a tank on the rail car? What's the effect of the bumping of that? Does it get loose? Does it rattle? So the tie downs, etc., are evaluated here. Tailoring is very specific. The test procedure is very specific, so tailoring is not really applicable. The interruption under test reestablish. Again, if you overtest, you have to figure out what happened. If you let it fall off the test fixture, you might have more damage that you have to reconsider. Multi-exciter testing 527 evaluates the structure of freedom from exposure to more than 1 degree of freedom, multiple directional forces. Calls for multiple exciter with single axis or multiple exciter, multiple axis kind of waveforms. A single axis might be where you have a long item where you need to expose various places of the exciter to touch various spots along a large atom from independent multiple exciters on the same axis. And multiple axes where you have the 3-dimensional vibration and shock. It's used for a customized waveform to evaluate the vibe and shock exposure. Some control strategy because you've got multiple things going on. You have to define how you're going to control those things. Complexity of input requires some detailed procedure development. Again, interruption, analyze, inspect, and resume. Sometimes there is detailed guidance for test articles. Sequence follows vibration in the shock guidance. Chipboard waveform replication vibration deals with the internal generated exciters and from environmental things. There's two different sections of this. The tailoring, much like we've always had, the test levels, duration, any control items, whether to monitor operation, things of this nature. Interruption, inspect it, and resume it if you're allowed to. Sequence, not really specified, but it's already in the overall test program. Another question?
We'd like to ask one more question to our audience. How do we determine the test duration? MIL Standard 810 specifies the duration for each test. Test procedure defines duration, life cycle analysis, or deployment locations. We'll give you a few seconds to answer the question. More votes are coming in. We have about 40% said test procedure defines duration, and around 40% also said life cycle analysis.
Well, I got to consider that both those 40% have some merit. The life cycle determines what goes in the procedure. Procedure should contain that information so you can evaluate it.
Thank you so much, Steve. We would like to have a call for final questions. Please enter any last questions you may have in the navigation pane. We've received quite a few inquiries on where to get additional information on this topic. There is a vast amount of content found on our website, www.environmentaltestanddesign.com. You can also email us at info@etdnews.com with specific needs, and we can direct you accordingly. Steve, here's a question for you. Why should a new unit be subjected to fungus testing since it is so difficult to recover, and what alternatives are available?
Well, a new unit doesn't have that false positive, as I kind of mentioned during the fungus discussion. If you get human oils and contaminants that are on the equipment from various things, you end up with a test that may give you a false positive, meaning that it supports mold growth, and then you're into redesigning and fixing something that didn't need to happen. It is a quite lengthy test, and handling of the spores is kind of critical for a lot of locations. Some labs, because of regulatory requirements in their state, have decided to quit doing this. So some labs that have the capability have medical people come in and work with it. So it's kind of a touchy situation. And as far as alternatives, if an operational test is required as part of the fungus growth, and you might be able to analyze and decide why it isn't, you could use some coupon testing for those things that just to decide if they support it or not. But sealed units have a little reason to have the inside boards and etc. exposed, so there's justification for not having to do a complete unit and expose everything there, so you could get away with a coupon, meaning the outer case of a sealed unit. There are some options to explore.
Here's another question. Is there a reason why I should consider altering the test sequence to do temperature testing prior to vibration?
Yeah, there's some cases where that comes into place. I remember a case that the temperature testing resulted in high failures during vibration. Resulted in the analysis showed that the dampening materials used for components, the components with a lot of mass, they had a putty compound to do that, a sealant. And during temperature tests, the sealant tended to harden and would allow vibration to affect the components and damage minor components within the circuit. And they had a huge fallout rate if they did the vibration after temperature?
We have received so many great questions that we will try to address in the future. Steve, thank you again for your time and expertise.
Well, thank you for inviting me.
And that's the end.